So I'm going to classify it by the number of sides. So 1, 2, 3, 4, 5, 6 sides. So I know that a 6-sided polygon is called a hexagon. So that's what it means to classify it by its number of sides. Next, I'm going to tell whether it is convex or concave. And the way that I test that is, remember, you would draw a line on the sides. If that line goes into the interior of the polygon, then it's concave. If it stays on the outside for all of the sides, then it's convex. So this would be convex because none of those sides, when I draw a line along them, enter into the interior of that polygon. The next one is using the area. So it says to find the area. It doesn't tell us what type of polygon it is, but as soon as I graph these 3 coordinates, I'm going to see that it's going to form a triangle. So I'm going to graph P, and it's -5, 4. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So this will be my first point. It's point P, and it's -5, 4. Then I'm going to graph Q, 1, 2, and then also up to the 4. And then lastly, I will graph S, which is at +1, -1. And now I'll connect the points and make my triangle. So go ahead, connect. Now, in order to find area of a triangle, I need to know the formula. So the formula for area of a triangle is 1/2 base times height. I need to figure out how long the base of my triangle is and how tall, or what is the height of my triangle. The height is always going to be where it's a perpendicular distance. It's going to be formed by a right angle. So I'm going to use my base as this horizontal line here, or this segment that's here. Now I can either choose to count the units, 1, 2, 3, 4, 5, 6, 7 units to get the length of the base, or I could have also taken the coordinates P and Q, and notice I could do either the distance formula with it or realize that the 4s are going to cancel out, and all I have to do is the bigger number minus the smaller number, take the absolute value of that, so 2 plus 5, and the base length is 7. Now to find the height, I do not want to use either of these sides because these are not perpendicular. So instead, what I'm going to do is figure out that my height actually goes from point S straight down to PQ. And because I'm drawing a vertical line, I can count the spaces. So 1, 2, 3, 4, 5. My triangle has a height of 5. So 1/2 base times height. I could multiply 7 times 5 and get 35. And now multiply it by 1/2, and the area would be 17.5 units squared. Let's try 1/5, where we're going to be classifying angles. So in 1/5, we learned about acute, obtuse, right, and straight angles. So when you have an angle that measures exactly 90 degrees, this is called a right angle. When you have an angle that is less than 90 degrees, this is called an acute angle. And when you have an angle that is greater than 90 but less than 180, this is called an obtuse angle. The next question is referring to the figure that's given to you. So in the figure, they're telling us that angle DEG equals 84 degrees. So let me go ahead, and here's D, here's E, here's G. So they're referring to the whole angle itself, and that's 84 degrees. So from here to here, 84. In order to find FEG, this little piece right here, I'm going to use my angle addition postulate. So what I'm going to be doing is I'm going to be adding DEF plus FEG. So let me go ahead and write this. Angle DEF plus angle FEG, and that's going to equal the angle, the entire angle, which is DEG. So I'm going to replace DEF with the 3x plus 10. I'm replacing FEG with x minus 6, and I'm setting it equal to 84. I'm now going to add my like terms for x, then I'll add these two. I'll subtract 4. 4x equals 80, divide by 4, and x equals 20. Now this was a mistake that some people made on the quiz. They would stop here. Remember, the question did not ask to find x, it wants this red angle here. So what I need to do is take x minus 6, my x is 20, so 20 minus 6, and this angle is 14 degrees. For the next one, it's telling me that I have an angle here, and we're going to label it as ZXW. And it's being bisected by XY. Soon as I see that I know that my angle has been bisected, I know it has created two congruent angles. They also told me in here that angle ZXY is 36 degrees. So because I know this one is 36, then this one is also 36. And then the question is asking me to find how much ZXW measures. So all I have to do is add 36 plus 36, and it's 72 degrees. The last slide, 1-6. They're telling us it's supplementary.
Wait, can you put it back, please?
Yes. Okay, and for the 1-6, the first one, it's telling us that 1 and 2 are supplementary. So that tells me I know when I add them, they're going to add up to be 180. So if they give me the measure of one of them to find the other one, I'm just going to subtract it from 180, and I get 83. So angle 2 equals 83 degrees. The next question says that they are complementary. So this tells me that they're going to add to be 90. So I'm going to do 90 minus 74, and that will leave me 16 degrees for angle 4. For EFH, right here is EFH. I can see that EFH and HFG form a linear pair. And I know that linear pairs are supplements. So I'm going to add 3x minus 6, which is angle EFH. And I'm going to add that to 2x plus 16, which is angle HFG. And I know when I add them, because it's a linear pair, they're going to equal 180. I'm going to combine my like terms, 5x, and I'll add the negative 6 and the 16. Gives me 10. I'll subtract the 10. 5x equals 170. Divide by 5, and x equals 34. Now, again, the question did not ask for x. It actually asked me to find the measure of EFH. EFH is this 3x minus 6. So I'm going to do 3 times 34. Once I multiply that, I get 102 minus 6, giving me 96 degrees for EFH. Then the next page, this time they want me to find the measure of ABC. So ABC is right here, and it's the x plus 9. Notice I've got the little red square here indicating that these two angles are complementary. So I'm going to add x plus 9 plus 2x and set it equal to 90 degrees. Combine your like terms. Subtract 9. 3x equals 81. Divide by 3, and x equals 27. Again, it did not ask for x. It wanted ABC. So now I'm going to plug 27 into x plus 9. 27 plus 9 is 36. Now, if the question also asked to find CBD, then I would take my x value, times it by 2, and get 54. And again, how you could check this is make sure that 36 plus 54 adds up to be 90 degrees, which it does. The last question here is asking, is it possible to draw a figure that contains exactly one pair of vertical angles? And this answer is no, and I will explain. I'm going to add a page. So recall that when you create vertical angles, their sides are created from opposite rays. So as soon as I intersect two lines here and the sides are opposite rays, I've created a vertical angle here and a vertical angle here. Now it also has vertical angles over here. So whenever you have intersecting lines here, you're going to have two pairs. You cannot have exactly one pair of vertical angles. So that is it for the warm-up part of the review. Your homework tonight is to complete the review that's on Canvas. And then we'll go over that review tomorrow and get ready for that test on Thursday.